Joshua, there's Josh. Oh, I'm missing that. Achilles.
I think at the trail is actually more fun. I like the especially because we didn't make it. Nah, it's just like simple 400 for you. We're just moving nothing, right? Forest will never talk.
Good. Michaela, grab your periodic table and a calculator. We'll go finish this other quiz up real quick.
Oh yeah. And then
I don't even know what you're supposed to know.
oh, I didn't do it. Thank God. I was actually just part of the girls that won the meeting. What? It does. Okay, I forget the most mentioned name before I ever see it. Not Mr. Seabird. And then Mr. Seabirds are like, oh, yeah, I love to do that. No, you don't. It's weird. You don't know Showfire.
All right, ladies and gentlemen, I hope you enjoyed your 4-day weekend. Hopefully you did something productive. Some of you should have spent a bunch of time probably studying, but that's only for the retake that you're going to have to do. So, all right, ladies and gentlemen, let's get to it. Joshua.
I actually thought I was going confident. Like I thought the test and then that's so weird.
Christopher.
Do you like my Spanish script? You can do it.
Oh, yeah, making like the
We're
ingredients.
making tacos.
You added avocado to your drink.
Okay, I looked up a recipe.
That makes sense. I don't add avocado. Wait, you didn't even add avocado to American tacos.
Joshua.
Oh my god.
Cheers.
We have like no faith in it. I made a whole video of me speaking it.
I need to see a video of you making it.
Isn't it?
Yeah.
No. I will make it.
Bet.
Okay. Sorry. That's why I was.
I said my mom makes tacos.
Oh yeah.
Also,
Can't
take a
wait.
picture.
Can't wait. Thank you.
Jasmine.
I don't have time.
That's what I just did.
Why is there another one? Daddy.
Morgan. I should have finished it.
Wait, I thought you were supposed to do about everything.
All right, ladies and gentlemen. So, Here we go.
You said only 12.
Exactly. These are 12, so there's only 12. Yeah, we'll see. He thought it was 16. He thought it was 16 points, but it's just 12.
That's what it's doing.
It was out of 16, so.
Oh, let's go.
What 3 elements make
You're right. I did say to do 12 out of the 16. Since 4 of them were done for you, that meant you had to do all 12. Sorry. But again, if you counted how many you did, you should have looked at it and said, "Oh, I only did 9."
There was 12 already. 9.
You didn't do 4 of them, so that's not ones you did. All right.
That whole 12.
That whole what?
The only 12 was 16. Exactly.
Okay, ladies and gentlemen. Here is number 1A and B versions. There is question number 1, ladies and gentlemen. Okay. Same formula used in both. The main thing was finding the formula masses and remembering that fluorine is a diatomic molecule so that you do F times 2. Now, your numbers could be slightly different than mine. Mine, I'm working off of an old periodic table that had them to a more precise measurement. So if you came up with around 38, I gave you credit. If you came up with around 44, I gave you credit. Those were the numbers that you should have gotten with 3 sig figs, ladies and gentlemen. Now, some of you chose to do it a different way. That was fine, as long as you came up with the correct answer when you were done. Questions? Okay. For those who have version A, I'll show you the next 2, and then I will show version B's in just a second here. So these are the next 2 problems for version A. Okay. Again, there are other ways to do this besides what I am showing you. Showing you one way. Question is, did you end up getting this answer and this answer, which is what you needed? Did you calculate your formula correctly? If you can't remember what tetra means, ladies and gentlemen, I am a phone call away. The people who asked me what tetra meant, I told them it meant 4. If you didn't ask, I assumed you knew. All right? So that's what you got for number 3, and that's what you got for number 4. I got news for you. You don't remember how to do this, you're dying in the next unit, ladies and gentlemen. You're dying in today's unit that we start. So, questions? Here's version B. Okay.
Oh, no, it still should have been.
So again, you needed to calculate the volume somehow. We needed the mass. Well, for that we used the formula. And then you put that volume into the formula to find the density. The one on the bottom, again, I cannot tell you how many people put in 45.6 and the other number in here. You can't just choose a number to put it in for something that it doesn't represent. This has to be in moles. So, and yes, you did have to go back to degrees Celsius because the question specifically asked you to do that. Again, please too, I know I didn't remind you of this. Check and make sure I added up the points on each page correct down into the corner. Please double check and make sure I added up the corners correct so they are the total that is on the front. Do not use a calculator when I do those, ladies and gentlemen. So if I made a math error and I cost you some points, you need to let me know. Here's the second page, ladies and gentlemen. This again is IDB. This up here will get you to an R value, putting in all of the standard conditions and then solving for R. Down here, there were a couple of ways you could have gone about this problem. Finding the partial pressure of A, then using it to find the total moles, then using that total moles to find the moles of B. You could have shortcutted it by putting the moles of B over the moles of A, the partial pressure of B over the partial pressure of A. You would have gotten the same answer either way, ladies and gentlemen. Questions? Same problem for number 4. Should have gotten the same 3.47. For number 5, the numbers obviously came out a little bit different, ladies and gentlemen. Again, 2 ways of doing it. Finding the partial pressure of A, putting it over the total, moles of A, find the mole total. Use that mole total along with the total pressure to find the moles of B. Same formula used twice. You can't find the moles of B directly because you don't know the mole total originally. You could have done it this way though, finding the moles of A, moles of B over moles of A, partial pressure of B over partial pressure of A would have given you the same answer. Questions? So, for number 6, ladies and gentlemen, okay, again, formula for sulfur dioxide, formula mass, okay, taking and using PV equals nRT to get the amount of moles. Moles times formula mass over mole gives you the grams of SO2 that were created. This is IDB. Again, finding the moles, formula mass for sulfur dioxide, giving you the grams. 2 points for your answer, 1 point for the correct answer, 1 point for sig figs and unit. Questions? Yes, no, maybe so. Same question for number 7 on both tests, ladies and gentlemen. Okay. If you have an aerosol can, what can't change about it? What doesn't change about my cup ever? The volume. The volume. Volume is a constant. If you're spraying a can, the pressure of the gas inside is going to decrease. Okay? Because you are spraying it. If the pressure decreases, the temperature should decrease. If the volume stays constant, it can have no effect on temperature. It's a constant. Constants don't change things. And actually, if the amount of gas goes down, temperature should go up. Why? They're both on the bottom of the formula multiplied together, which means they're in an inverse relationship. So then the only possible answer for why the can gets colder is because the pressure is decreasing, causing the temperature of the can to decrease. Because we know that's what happened. What variable caused it? Well, the only one that could have would have been pressure. Questions, ladies and gentlemen? Okay. What unit must temperature be in? It has to be in the unit of Kelvin. 2 reasons. Number 1, no negative numbers, absolute scale. However you wanted to say that, that was fine. But you can't say absolute scale and no negative numbers. They mean the same thing. The other reason is changes around our temperature are not as great in Kelvin. Again, it was 1 degree out about, 3 or 4 days ago outside. Today it's 29. That would be a 29 times increase in the pressure on us from that day to today, if it were in Celsius. But in Kelvin, that's 274 to now 302. That's not that big a change, ladies and gentlemen. That is not that big a change. Okay, sorry. I might have originally intended on leaving some more blanks on here. Sorry if that confused you. But again, this was a gift, ladies and gentlemen. The only two that were difficult at all were these two. Why? Because you had to figure out the variables and the constants. If you know what the two constants are, you know what the two variables are. If you know what the two variables are, you know what the two constants have to be. Okay? And then you needed to know which law was which. Questions? Thank you. Okay. I did accept both definitions of pressure only because I did not specify that it had to be the KMT definition of pressure. Temperature, average kinetic energy of particles, matter, volume, amount of space it occupies, and amount of gas is the number of moles in the sample or the number of particles I accepted. There are your units, ladies and gentlemen. Again, same question that you were given on your first quiz in this unit. Same exact question. Okay? Our bonus questions. The definition of chemistry, the science of the study of matter, its structure, properties, composition, and the changes it undergoes. What four elements combined would make up a student's favorite day at this time of the year? Snow day. Sulfur, nitrogen, oxygen, tungsten. Okay? And then what three elements would make up what tired science teachers like to take? That would be naps. Sodium, phosphorus, and sulfur, ladies and gentlemen. By the way, some of you came up with coffee too. I accepted that. Very creative. I do have an idea of a question, of an answer in mind on a problem like this, but if you come up with something that is as appropriate, I will accept your other answers. But, ladies and gentlemen, notice what it says here. What three elements? Not what symbols, what three elements. So if you only got 1 out of 2, it was because you gave me symbols that made something, but not the names of them because I asked for the elements specifically. Okay? Oh, I think there was one more on the last page. For those of you who are English language majors, it did not really matter here. Because which is correct? 8 and 8 is 15 or 8 and 8 are 15? 8 and 8 is 16 last time I checked, ladies and gentlemen. Not 15. So, neither one is actually correct. Questions? Okay. Now that we got that out of the way, ladies and gentlemen. Yeah, they're yours. Okay. Stevie. Hayden. Irving. Jack. Joshua.
Wow.
Pierce. Angel.
Oh wow. Show up.
Michaela.
Eddie.
Andy.
No, 90. How do you know what that is? No,
Ariana.
es que dejé no contesté.
Christopher.
41.
Jasmine.
41.
Por ciento.
Joshua.
Por ciento era como 60. Es 60.
Morgan. JVB. Eric. Steven. Hey,
Aquí también. Aquí también. Aquí
Chenza.
también.
What have people left?
Did I give you one?
Never
Never mind.
I do need to double check one thing, ladies and gentlemen. And that is, in my class, if you do an assignment, you are guaranteed of at least a 50% on that assignment. I need to go back and double check the test grades because I don't remember if I did that for people who got less than a 50%. So if you did get less than a 50%, I will be changing it to give you at least a 50% on the test grade. I will make that adjustment. You can check your grade at Infinite Campus. I don't know how many, if any of you, that applies to, but that is something that I do need to check, and I will check because I'll write myself a note right now, and I will do that. Okay. Okay. The one thing I do want you to check, ladies and gentlemen, is I do want you to check and see if you are missing any labs or any quizzes. I don't even bother to put homework on here anymore. Okay? Again, you don't do the homework. Are you happy with your test grade? Because you had plenty of opportunities to practice what was on the test on the homework. Okay? So, your choice. Okay? Treating you like an adult. You need to know what you need to do well in the class. Not doing homework? Hey, I hated that kid in class too. I hated the kid at college who showed up 4 times a year. Test day. That was it. Walked in, took the test, got an A, walked out. He could sit in his dorm room, look at the book, figure everything out, didn't need the instructor at all. Great, wonderful. I was in class every day. I did all the practice problems, and I struggled through classes. That's who I was. But if I did any less than that, couldn't make it. You got to figure out who you are. You got to figure out what you need to do to be successful. By the way, doing the problems while you're looking at the answer key, probably not going to make you successful. Doing the problem, checking the answer key, seeing if you got it right, seeing if you're using the correct formula, seeing if you're getting the correct answer, seeing if you put the numbers into your calculator, if they come out to what they are supposed to be, that can make you successful. Okay? That can make you successful. All right? Couple of things. Congratulations, you guys are changing how I'm going to do things next year for sure. What I mean by that is they tell me that I cannot penalize you for late work. But some of you are not turning in labs to me. You're just sitting there and waiting on it. So next year, I'm not penalizing anybody for late work. But next year, I am rewarding students who turn things in on time. You turn in a lab or a quiz on time for me, you can get a grade higher than a C. If you don't, you will not be able to next year. And I'm not punishing you for your behavior. I'm rewarding those of you who are choosing to do a good behavior. Okay? You guys have made it clear that I cannot just say, well, if it's late, you can turn it in whenever you want. That doesn't help you. The idea behind our last lab was to work through the calculations that you needed on this test. You now go and do those calculations and turn it in. That is wonderful. But you know what? It didn't help you on this test when you needed it. Okay? I'm giving you a packet today. You do the problems in that packet, okay? You're going to probably be very successful on this next test. You don't, you're not going to. And here's what I'll tell you. Your next test is 3 or 4 questions. That's the entire test. 3 or 4 questions. But it's going to take everything that we have learned thus far and puts it into 3 or 4 questions. Okay? And there's no BSing on this part of this test. You either know it and can do it, or you have no clue. I am here almost every day except for the last day of the week. I am here at 6 o'clock in the morning. I don't recommend you come in at 6 o'clock in the morning. But you need help and you want to come in at 7, 7:10, I am here every day. After school, I have meetings some days. Fridays, I'm not here. Okay? But I'm here most days after school if I do not have some kind of meeting. Mondays are meetings. Thursday this week is parent-teacher conferences. I'll be around after school today. I will be around tomorrow after school. Okay? If you have questions, if you need help with something, please come and see me. I will give you all the help that you need. Okay? But again, not gonna go, hey, you need to come and see me. You didn't do well on the last test. You figure it out. Figure it out if you want to improve your grade or not. Okay? And here's what I will tell you. Working from behind is a terrible thing to do. In other words, now you're going to be still working on Unit 6, some of you. Well, we are doing Unit 7. And I hate to tell you, but Unit 7 uses the stuff from Unit 6. So I don't know how you're going to be able to use the stuff that you don't know unless you come in and get help. About 6 weeks left, 5 weeks left to the semester. 3 weeks on this next unit that we're doing, then the rest of the time on Unit 8. Then you will be done with me, ladies and gentlemen. Okay? So, some time to go. Definitely time for your grade to change, either in a positive manner or a negative manner. Okay? But again, you need to get help. You need to come and see me. Okay? Or, here's the other thing. Utilize your time in class more wisely. Okay? So when I give you time, when we go in back and we're working on problems, if you need help, call me over. But don't sit there and struggle or be like, oh, yeah, you know, my partner did this problem. I got it. No, you don't. Unless you do the problems, you don't got it. Okay? It's easy to sit there and look at the problem and go, yeah, okay, I got it. And you have no idea how the person began it, started it, did things in the middle, or finished it. So, again, do what you need to do, ladies and gentlemen. I am here to help you. Everything that we do in class goes into a video online. You miss a day? Watch the video. You miss a day? Come and see me. We'll go through things. But again, it's all on you. There's a big old word at the top of this page, ladies and gentlemen. Don't be freaked out by it. I'm not going to ask you to define it. I am going to be able to ask you to know how to use it, though. Unit 7, EISN is published and in your notes in your computer. Please open it up and please get to it. Oh, that's right. I gave it to you. Wait, I thought you were supposed to be. Okay, tomorrow? Okay. 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 So the word is stoichiometry, ladies and gentlemen. If you're looking at the top of that going, what the hell is that? The word is called stoichiometry. What it is, ladies and gentlemen, is in chemistry, the reason we've been saying and figuring out how many moles there are in so many grams of something, the reason that we have been using ideal gas laws, we know the pressure, the volume, the temperature of a gas to figure out the number of moles of something. And the reason that we will learn about molarity in this unit is because everything in chemistry revolves around the mole. Everything. If you have no idea where to begin a problem, get it into moles. Because from moles, you can go wherever you want. And the power of the mole comes in when you look at a chemical reaction. It shows a molar ratio. So much of this reacts with so much of this to make so much of these things. Ingredients go into making something up. Flour, eggs, milk, oil go into making up a cake. You want to make 2 cakes instead of 1, what do you do to the recipe? Double it. But in that recipe, there is a ratio of this to this to this to this. And then here's what you get. So much. The same thing is true in chemistry. From any reactant, you can figure out how much product can be created. You can figure out if you have this much reactant, how much of the other reactant do you need to react with it? And it's all through stoichiometry. But it's all also using what we already learned. If I'm going to give you a gas, I've got to give you its pressure, its volume, its temperature, and then you can calculate the number of moles of gas that I gave you. If I'm going to give you magnesium ribbon like we did in the lab, you can go and you can find the mass of it. Mass doesn't really help me. Well, kind of. But what's better than mass? Moles. And you can convert from moles to mass because in Unit 5 we taught you how to do that. Now there's only one way I haven't given you. And that is, what if it's dissolved in water? It's aqueous. You are correct. But how do we measure something dissolved in water? Well, we do it in something called molarity. And that's what we're going to talk about today. And literally what it means is, okay, if I give you a solution that is so strong, how do we figure out how many moles? Because guess what? We're always trying to figure out the number of moles. Because once we know the moles, we can use a ratio to figure out how much product would be created. Okay? Questions? Now, just because you have a ratio, 4 out of 5 dentists recommend sugarless gum for their patients who chew gum, ladies and gentlemen. Does that mean they surveyed 5 dentists? What if they surveyed 10 dentists? How many would recommend sugarless gum? How many? 4 out of 5 dentists recommend sugarless gums for their patients who chew gum. I asked 10 dentists, how many are going to say sugarless gum's the way to go? 8. What if I asked 20 dentists? Because it's a ratio. 4 out of 5 is a ratio. You can extend that to as many dentists as you want. Okay? And a matter of fact, we could even cut ratios down into smaller amounts. Now, it's hard when you talk about dentists, because you can't have a half a dentist. But can you have a half a mole of something? Could you have a quarter of a mole? Could you have 0.00001 of a mole? Yes. But the ratio still exists. The ratio still exists, ladies and gentlemen. And that is what we are going to show you. But oh my gosh, you know what? To do a ratio, you need to write a balanced chemical equation. Whoa, balanced chemical equation. Yeah, you remember we did that in Unit 4, where we balanced chemical equations. By the way, you will never get a chemical equation to balance, so if you do what? If you don't have good formulas. Ooh, wait, that's Unit 3. Naming and writing formulas, right? Unit 3, Unit 4, Unit 5, Unit 6. All back in this unit, ladies and gentlemen. All back at, oh my gosh, I hope you can name an acid. I hope you can write a ternary ionic compound. Hope you know what a covalent compound is, because they're all back. Now, think about this for a minute. You guys are kind of lucky. You know why? You didn't have a trimester off. Think about your friends who are not in the class right now, who got to remember all that after having one whole trimester off. Yeah. Sorry. Sorry for them. I really am. I really am, but there is nothing I can do about it because that's the way the schedule falls. Okay. So, ladies and gentlemen, stoichiometry is the word. It's the study of molar relationships in a chemical reaction. That's what it basically is. It allows us to predict how much stuff is going to be created if we know how much stuff we began with. And by the way, that goes back to the law of conservation of mass. You cannot create more stuff than what you start with. That's it. And every chemical reaction stops as soon as you run out of something. You want to make cakes. You want to make as many cakes as you can at home. Go ahead and make them. But when you run out of eggs, you ain't making any more cakes. Because as soon as you are out of one thing, stops production. Same thing with a chemical reaction. Okay? So, here are our topics, ladies and gentlemen. Only about 40-some slides to get through this unit. Okay? So, whoa, volume to gas to mole relationship. Wonder if we're going to use PV equals nRT. Mass to mass stoic relationships. Grams per formula mass, Molarity, limiting reactants, ionic compounds in water. Wait, we did those. We talked about what happens if you put something into water. It either breaks apart into ions or it stays together as one thing, right? Good. You're going to need to remember that. Yep, good. Excellent. Ions and net ionic equations. I even showed you those before we did the final exam in the first unit or first half of the course. So, steps to stoic. Don't expect you to write this down. Don't expect you to ever be asked this on a test. But this is what we are going to do in this unit. You're going to write what is called the skeleton equation. Skeleton equation says this reacts with this to make this and this. Now, I've only asked you to ever predict two kinds of reactions. What are they? The products can be predicted in what two kinds of reactions that we did in unit 4? No. Synthesis, decomposition, single replacement, double replacement. Which two of those four?
The stories.
Yeah, which two of those 4 stories can you tell?
I can tell the one that I was.
Double replacement.
Yes.
Double replacement, we can predict the double replacement reaction. We could take the two cations and we could switch who they're with, just like at the dance. The two guys switched who they were with at the dance. And we could talk about what would be created. Now, for a double replacement reaction to occur, you have to find a what? No. What tells us that that double replacement reaction occurred? What are some of the products that could be created? A solid, a precipitate. Reference sheet number 2 we have. What? Nope, aqueous doesn't mean that it reacted. Precipitate forms, a gas forms, or liquid water forms. That means that a reaction has occurred, a double replacement reaction. What was the other kind of reaction we could predict? The other side of that second reference sheet. Say it louder, Phoebe. Single replacement. We can also predict those. Okay? Will the single replacement happen? Can I borrow that, Stephen? Is the metal that is alone higher up than the metal that is in the compound? If so, the reaction will happen. If not, guess what? No reaction. Nothing to do. You write down no reaction. Woohoo! You move on. That problem is completely done by writing 2 words. No reaction. Completely done. Okay? Then we got to balance the equation. Now we got all these reactants and products, but we have to have the same amount of every atom on both sides of an equation. Count up the atoms. We add coefficients to make sure we get to the same amount of everything on each side. Balancing chemical equations. All I'm going to do is review that, ladies and gentlemen. I'm not teaching it again. Identify what you are given. Are you given so much of each reactant? Are you given so much of a product that is created? What are you given? They will tell you that in a problem. You begin the problem with 30 grams of zinc metal. Okay, good. Now I know that. I can take that 30 grams of zinc metal and convert it into? We're not paying attention, obviously. Convert what you're given into moles every single time. They give you moles. Good news. You don't have to convert anything. What are the chances of me giving you moles? Not real good, ladies and gentlemen. Not real good. Identify what you're given. Identify what you're looking for. Does it want to know how much of the other reactant I need? Does it tell me how? Does it want to know how much product is created? You're going to convert what you're given into moles. 3 ways. Mass to moles using formula mass, unit 5. Volume to moles using PV equals nRT. Volume and molarity, that one we haven't learned. That one we're going to learn. Volume times molarity will actually equal the number of moles you are given. Show you how to do that today. Then you're going to use a molar ratio that you're going to get from a balanced chemical equation, which means if your chemical equation isn't balanced, you don't get the right ratio. You could compare reactant to product. That is normally what we'll do. You're given this much reactant. How much product do you create? You could compare reactant to reactant. Or you could compare product to product. By the way, you already did reactant to product. Anybody know when? Your last lab. Because what was our product in our last lab? Gas law lab. What was our product? What was our product? What did we create? You gave me the one I didn't want. What was the one I do want? What was the other thing in there? Hydrogen gas. And we were given its volume, its pressure, its temperature. What did we have to find? The number of moles, right? But that number of moles that we were supposed to get depended on what in that lab? Oh, went back to something even before that. You're right, it did depend on that. That's the PV equals nRT that we did at the end. The mass of the magnesium ribbon. The moles of magnesium, the reactant, determine the moles of hydrogen gas. We were getting the product. You were doing Stoich last unit, ladies and gentlemen. You were doing it last unit. One of the things we didn't have to do is we didn't have to look for a limiting reactant because we said we used excess what in that lab? No, we didn't use water. What did the actual magnesium ribbon react with? That dangerous stuff. Phoebe, you are the master of specificity. Specificity. Yeah, what was it?
Hydrochloric acid.
Hydrochloric acid. Thank you. Then we did fill the tube up with water, but that wasn't what was reacting with the magnesium ribbon. Okay? Okay. So, but we said there was excess acid. We didn't care how much. We knew there was plenty. We knew we were going to run out of the magnesium ribbon first. And then ultimately you're going to report your answer into a proper unit. I want to know how many grams. I want to know how much volume a gas is going to occupy. I want to know what the molarity is going to be of a solution. Guess what? That is the exact opposite of what you did at the start. So instead of using grams to get into moles, you're going to use moles to get into grams. Instead of using the volume to get to the amount of gas, we're going to find the volume, and now we're going to figure out how many, or we're going to use the moles to figure out how much volume was created. Or we're going to use molarity. Okay? So there's not a lot of different ways of doing these, but there's a lot of steps to them. So let's talk about molarity, ladies and gentlemen. Molarity is the number of moles of solute, a dissolved substance, per liter of solution. Our acid that we used in the lab with the magnesium ribbon was 6 molar hydrochloric acid. 6 molar. That means that in 1 liter of solution, there are 6 moles of hydrochloric acid. Did you use a liter of solution in your lab? No. So did you use 6 moles? No. But if we know how much we used, 25 to 30 milliliters, We can figure out how many moles we use because it is a ratio. Ratios are easy to find. Okay? We express molarity as moles over liter. This is kind of like density, grams over liter, except now instead of grams, we're using moles over liter. And we write it as a capital M for the unit. A capital M represents moles over liter. Question. Okay? For example, 3.25 molar sodium chloride. Molarity allows you to convert liters of solution into moles. This is the third way. This is the final way that we will give you information. We will give you grams, we will give you volumes, or we will give you molarity. Now with molarity, it's a solution. And I have to give you a volume as well. But it is not the volume of a gas, it is the volume of the solution. The liquid. All of it. Okay? Questions? So if I have 50 grams of salt dissolved in 1 liter of water, 50 grams of salt in 1 liter, what if I split that into 2 containers with a ½ liter each? How much salt would you expect to find in each container? Why? Thank you. It's a ratio. It's half. And you're exactly correct. Because it's a solution, because it evenly distributes. Oh my God, that goes back all the way to Unit 2, classification of matter. A homogeneous mixture, evenly spread out. Means that if we take half the solution, we should get half the moles. We take half the solution, we should get half the grams. We take a quarter of the solution, we should get a quarter of grams. Science and chemistry is very predictable. Okay, so here we go, ladies and gentlemen. What is the molarity of an aqueous solution containing 40 grams of glucose in 1.5 liters of solution? Okay? Now, first of all, to find the molarity, we need what 2 units? Moles and liters. Which one do I have in the problem right away? No, I don't. I have liters. What do I have in the problem? What? Grams. Can we get from grams to moles?
Yes.
I hope so. 40 grams of C6H12O6. 1 mole of C6H12O. Where the heck did I get 180.18? Formula mass of C6H12O6. 6 times 12 is? Yes, 72. Good. 12 times 1 is? 12. Good. That's 84. 6 times 16 is? 96. Good. You guys are on top of your math today. 96, 12, 72, 180.18 grams. Converted into moles. Did that in Unit 5. Correct? Questions on this? So now to find the molarity, we take the moles divided by how much solution is there. Now, this has to be in moles, right? What does this have to be in? Liters. So what do you do if you're given milliliters?
Convert it to liters.
Convert it to liters. And all we do to find molarity is take the moles divided by the volume of solution. That gives us our molarity. Notice capital M here. What does that mean?
How many moles you need?
How many what?
How many moles you need?
How many moles there are in a liter? How many moles there are in a liter? Questions? How many moles of silver nitrate are present in 255 milliliters of 0.350 molar solution? Okay, so here's what we got, ladies and gentlemen. They're ultimately asking us to find moles. By the way, silver nitrate. I need a formula, right? What's the formula for silver nitrate? AgNO3. Thank you very much. AgNO3. I do not like using molarity in problems. Let me explain what I mean. I am, and I have shown you multiple times, that I am a huge fan of units. Units will help you. Units will show you how to set things up. So if I have 255 milliliters times 3.50 moles, is anything going to cancel out here?
No.
None that I can tell. But if I rewrite this as 3.50 moles over liters, now will milliliters and liters cancel out? No, but they're really what? They're both measuring volume, correct? Okay, so what do I do to this to be able to use it with this?
Divided by 1,000.
No, my gosh. Actually, sorry, Eric, you were right.
Yeah.
Sorry, I jumped the gun there. It's the first time Eric's been right. I wasn't used to
wow.
it. No, I'm kidding. Sorry, Eric.
It's okay.
Okay, so we take our 255 milliliters and we're going to convert it into liters. And Eric was right, ladies and gentlemen. Mark this day on the calendar. Eric was right. We are going to divide by 1,000. So that's where this 0.255 liters comes from. Questions? Now, you remember when we talked about gas laws? And we said units didn't matter in Boyle's law and Charles' law as long as the units were what? The same on both sides. But then we got to the R values. And in the R values, the different R values were determined by what unit of pressure we used, correct? And then we had to use Kelvin for temperature, because anytime we put temperature into a calculation, it had to be in Kelvin. But what else was unique about the R values that made us use a certain unit?
Wasn't it like equal to STP or something? It was like STP.
That was, you're absolutely correct. But our units for the R values, temperature had to be in Kelvin. We picked the R value based on the unit of pressure. So 62.4, 8.31, 1.01, what, you know, that. But the one thing we had to be careful of was that our volume needed to be in.
Oh, no, it's liters.
Needed to be in liters. Because the R value is calculated using liters, our volume had to be in liters. Normally, when we measure things out in the lab, we measure them out in milliliters. The problem is molarity is moles per liter. So if we are going to use this and this together, we have to get this into liters, always. Okay? You have to get into liters. This could be a small amount. That could be like 50 milliliters. You still need to get it into liters because molarities are always moles over liter. It is the only way to convert it, is to get it into liters. So that's what I'm doing here. Now again, remember, you don't have to show me this calculation. You need to do it. You need to do it correctly. But if you just do this, showing me the correct number with liters, I'm okay with it. And now when we take it times it, what happens to our units here? What cancels out? Liters and liters cancel out. We are left with moles. We are left with moles. Now, I do want to show you something, ladies and gentlemen. Okay? Does everyone see where we got our answer from? Any questions on that? No. Okay. Now, do you remember when we did this? 32.0 grams of oxygen equals what? One what, Phoebe?
I said that.
Well, I'm glad you guys were willing to be, confident enough to share with your neighbor and make sure I didn't hear it. And from this, ladies and gentlemen, we could do this. Over what? What could we do with this fact? 1 mole over. Or we could put 32.0 grams of oxygen over. Doesn't matter, correct? This could go to this, or it could go to this, depending on how we needed to use it, correct? This is a conversion factor, right? So much of this is equal to so much of this. It doesn't matter which one we put on top and which one we put on the bottom. How do we determine which of these we want to use? Why would we use this one time and this one another?
If you cancel it out.
What are we canceling out in this one?
You want to cancel out the grams or something.
So if you were in grams, we would use this one because grams would cancel out. What unit would we end in? Moles. Why would we use this one?
To get into grams.
You're in moles and you want to get it into? Good. Perfect. Excellent. Some memory things going on here. We're doing good today. Okay? That's why sometimes I look at this way, ladies and gentlemen. What does it equal? Anybody? Someone have the courage to say it out. What source you're going to do? Be wrong? Tell you what, Josie, if you're wrong and you die from it, I will never ask you another question in class again. Anybody?
Me, Grant?
I'm already wrong.
What?
112 grams.
How'd you get 112 grams?
No, times 32.
Why'd you multiply by 32?
Plus 32 grams.
No. Okay, I kind of see where you're going there. I do. I honestly do. Oh, that's all you wanted? That's all you wanted as a red?
I know, Mom.
How come we can say that? Because this is 3.50 moles per 1 liter. Well, if this over this came from the fact that these two were equal, right? These two over each other must mean this is equal to that volume, correct? What that means is I could write it this way, or what could I do to this if I really needed to? When it's written this way, what could I do to it? I could flip it. I could flip it. If I needed to, I could flip it. Why did I have to flip this here?
To get into a specific unit.
Okay, what unit am I given here and what unit am I trying to get into?
You're giving grams and moles, but you're trying to get into moles.
You're only getting.
Oh, wait.
Slow down.
Wait.
I would use this if I were given what? Trying to get to what? Grams trying to get to moles. I would use this if I were given moles trying to get to grams. Here, I use this because I was given liters trying to get to moles. When would I use this?
When you're getting liters.
If I'm given moles and I'm trying to get to liters. So if I want to do the exact opposite, I flip my conversion over, right? Anytime you have a fraction in science that you're using as a conversion, the top has to be equal to the bottom. The top has to be equal to the bottom. And then I can flip it over and I can use it the opposite way if I need to. Questions? Feeling confident, Christopher, with that smile look on your face right now? Why not? Well, the good news is it's going to get worse. How many milliliters of solution are necessary to have 12.5 grams of magnesium chlorate if the molarity of the solution is 0.250 moles? Okay. So, 1.25 grams of magnesium chlorate, right? What can I convert that into? Okay, it's up there for you. Come on, somebody tell me. Well, not 1 mole, but I could convert it into moles. When you're not sure what to do, take what you're given and get it into moles. Okay? So I'm taking this 1.25 grams here, and I'm getting it into moles using what? What? Formula mass. This gives me the moles of it. Okay? This gives me the moles of it. Why do I want to get into moles? Well, because I'm given a what about this solution? What is this? Molarity. I'm given a molarity. But ultimately, I want to get into to find what about the solution? What did the problem ask me to find? What were the first 4 words? The milliliters of the solution. Okay? Well, in molarity, yeah, that worked out well. That is moles over liters, correct? Correct? Molarity, moles over liters. So I've got to be solving for the liters part here. Got to be solving for it, right? Okay? So take our grams, convert them into moles. Questions on that? Okay, might as well review this while I'm at it. Magnesium, what's the charge?
+2.
Chlorate, what's the charge? -1. Chlorite, formula.
Oh.
No, O would be oxygen, but thank you. You're close though. ClO2 would be chlorite. What? Well, we're going to need it in parentheses because where does this 2 end up?
Outside.
By the ClO3. Where does this -1 end up? By the Mg. So we end up with Mg, parentheses, ClO3, parentheses 2. That's how we get that formula in case you forgot. We'll do a little bit of reminding over the next few days, ladies and gentlemen. Questions? All right. Magnesium. 24.305, correct? Mass? Yes? Plus How many chlorines?
2.
2. 35.43. Plus, how many oxygens?
6.
Times 16. That's where I get the 191.21 grams from. Questions, ladies and gentlemen? Yes, no, maybe so? Grams, 2 moles, formula mass. Moles times the molarity. But what did I do the molarity here? Flipped it. Why?
To get into liters.
Because I'm going from moles to liters, not liters to moles. Doing the exact opposite that we just did. So what did I do to this? I flipped it. Okay? Moles and moles will cancel out. Left with liters. Again, always going to be liters using this. So it came out 0.26149 liters needed in.
Oh, milliliters.
Milliliters. So Eric,
Wait. You multiply it by 1,000.
yes. We multiply it by 1,000. Eric is 2 for 2 today, ladies and gentlemen.
Let's
My
go.
suggestion, Eric, find somebody over the age of 18, have them buy you a lottery ticket because you are on fire today.
Yes.
On fire.
Let's go.
Questions? Okay. Tomorrow we will be practicing this. Okay? Tomorrow we will be practicing this. Questions? All righty, ladies and gentlemen.